In a previous video, I described a near collision between Mars and Jupiter that created most of Mars's surface. This video is going to focus on the most obvious and easily explained evidence. The more esoteric evidence will be in later videos. This is the easy stuff. The first piece of evidence is the Helis basin, or more precisely, the vast scale of it. It's a massive hole in the side of Mars, too massive to be an asteroid hit. If an asteroid made it, it would tend to melt the crater. The energy of impact can be calculated to about 10 to the 15 kilotons. That's about the equivalent of 6,000 Hiroshima bombs for each and every person on Earth. That tends to melt things. If all that energy went into heat, it is enough to melt the entire surface of Mars to a depth of 7 kilometers. Just a tiny fraction of that obliterates Helis basin. This makes the asteroid theory dubious, not impossible, but highly improbable. However, the basin being created by explosive decompression induced by Jupiter's gravity is a cooling process. As an addendum to this point, it should be noted that the antipodal region consists of the largest volcanoes in the solar system. These were presumably created via shock waves traveling through the planet, indicating a catastrophic creation of the Helis basin. The second piece of evidence comes from the amount of material torn from Mars. This scenario creates orders of magnitude more ejecta than an asteroid collision. The mass of it is vast. Let's say the equivalent of 50,000 asteroids the size of Mars's moon Deimos. Now, these are launched over a spectrum of trajectories, with the slowest ones crashing back into Mars and the fastest ones being shot into Jupiter. Now, since there are so many asteroids, some of the more rare outcomes become likely. For example, between the ones that crash back and the ones that fly off into space, there is a narrow band of those that go into orbit and become moons of Mars. Similarly, there is a narrow band of those that become moons of Jupiter, and even narrower bands corresponding to rarer destinations. The interesting thing is that all these destinations are populated with asteroids. This scenario not only explains this, it predicts and requires it. Let's turn our attention back to the asteroids that fly off. The common conclusion is that these created the asteroid belt. This is partially true. Their expected mass can be calculated, and it is about 3% of the mass of the asteroid belt. However, the asteroid belt is a group of 30 small families of similar characteristics, all of which are about the right size. This would imply that not only is one of these families formed from the Martian ejecta, but collisions similar to this have happened before. The third piece of evidence comes from the craters the returning asteroids make. These asteroids are only traveling at a fraction of the speed of a typical one. Thus, the craters they form should be shallower than expected. The craters on Mars are indeed much shallower. The posited explanation is that they are filled with snow that only accumulates inside the craters. This is another example of a phenomenon that is predicted and required by this scenario, and is poorly explained by current theory. Now let's combine these three ideas: the lack of melting, the vast distribution of projectiles, and the debris-filled craters into one idea: that one of the large unmelted pieces of Mars was launched in a suborbital trajectory. Thus we should be able to find a mountain inside a crater. Now normally mountains are never found in craters for obvious reasons, but here's one. It is called Aeolus Mons, and it is the size of Mount Everest. And if one looks very closely, you can see the Curiosity rover driving up to it. This is providing, and hopefully will continue to provide, a wealth of new supporting evidence for this scenario. The next video will address the most common question about the impact: What was the trajectory of Mars before and after this event?